Hello everyone, my name is Apoorv. Along with me, I have,
Anirban.
as mentioned before, this is a session of collaboration of DSC-KIIT and XoRphilic. So far, in the first session, we have been making our first augmented reality project, that is a tap to place, where we use the AR Foundation package so that we can place a 3D model in the real world. Okay, so if you haven't watched my first session, stop the video, scroll down, the link is in the description, and you can come back here and do the rest. So, in the first session, as mentioned, we have started a game, that is a basketball game. Okay, so we will be completing this project in this session. So, back to you, Anirban.
Okay, so as Apoorv said, we will be completing the basketball game in this session. So for completing the game, we had already placed the basketball hoop by the end of the part one of the video. So in case if you haven't watched the video, of course, go there and check that video out first, and then come back here. So now what we will do is use that basketball hoop and add a basketball itself into the scene, and then we'll be using swipe controls to play to shoot the basketball into the basketball hoop. So I'm sure you are very excited to make your first markerless AR game. So let's get on with the video. So we ended our last video by placing the basketball hoop into our scene. So let's start today's video by first bringing in the basketball we will be using. So here we have the basketball model. Again, both the models will be available in the description below to be downloaded. So you can simply download and use it in your game. So here we have the basketball model. Let's place it as a child of prefab to be placed. So here we have the basketball. Let's reset the transform, and here we have the basketball. So similar to how we had extracted the materials for the hoop, let's extract the materials of the basketball also in the materials folder. Yeah, so we can see there are two materials here, black and orange. So let's go into our materials folder and find those two. So orange and black here. So for orange, let's select some good orange color. This one looks good. Let's increase the smoothness a bit. Yeah. And for the black, let's select a dark black color and maybe increase the smoothness a bit metallic maybe. You can play around with these parameters and have the color that you want your basketball to be. You can also make a whole different new kind of basketball for your game. That's up to you. So here we have the basketball model in our scene. So also similar to what I had told you in the last video, that we want the basketball hoop to be a bit in front of the camera so that the user can see the whole basketball hoop when playing. We also want the basketball also to be a bit in front of the camera, not exactly on the camera itself or on the player itself. So so we can move the basketball a bit in front of the camera. So like I think around 2 or 2.5 will be good. And we can also move the down the basketball to match sort of the hand level of a user. So like maybe -1 I think will be good. You can switch to the game view here and change this to portrait mode because we will be playing in portrait. So have a sort of idea of how it will look. Here you can change the resolution and have a look at how it will look in different resolutions. So this is 800 and 480 resolution. Then this is another resolution. Sorry, we won't be needing landscape. So here you have the portrait. In case you are not getting so many different resolution options, it's because you're in your build settings, you are in your PC Mac version. So switch it, come to Android and click here to switch platform, and then come here, you will see the different resolution options. So yeah, we have the scene ready. Before we go on into the coding part and show how you can handle the swipe input for your basketball, we actually need to make a toggle sort of, which isn't necessary, but when you are playing a game, you don't want that those planes which are being detected to be always visible or being detected actually. So to turn off the visibility of the game, we'll be actually making a toggle. So let's come here into UI and make a toggle. So any UI element you in Unity if you create, it comes with a canvas of course. So let's switch to 2D and we can see our toggle here. So it's actually at the very bottom, but we actually want it here. So let's change this to top left. So if you didn't have this, press Control and Alt in your keyboard, and there Then you can select top left, so it will be anchored here in top left. Then we need to change the height a bit, so we don't need that kind of a height actually. So I think a height of around width of 300 and a height of 60 will be good. Let's switch to our scene view to have a look at what it's looking like. So it's still a bit small. So again, anchor it so that it's anchored properly at that point. So now let's increase the toggle size first. So this toggle is looking very small actually. So as for the toggle, let's stretch it completely in the left side. Sorry, so this one stretch left, I think, because we want the toggle to cover the whole area here. And as for the width, you can select 60, I think will be good. Yes, 60 looks good. And give it 30. It's looking, oh, okay. It's looking a bit small because I forgot to do one thing. When you are bringing the canvas, when you bring a canvas into Unity, it comes with the default mode of constant pixel size, but we actually want it to scale with our screen size. So here, if you go into scales in right now, you can see a bit of a difference. To make that difference more visible, you can change this into a different resolution scale and then increase it to maybe zero point 0.6. I usually keep it zero point 0.6 because it looks good in zero point 0.6. Okay. So I think this size will look good. As for the check mark, we will make it fit the whole thing and maybe give it a 5 padding all around. After that, the toggle seems to be a bit too much into the top left. So let's bring it a bit down, maybe. Yeah, something like this. I think maybe minus 70. This looks good. Okay. And as for the text here, we can change the text to maybe visualization toggle. Maybe make it center and this, and I think this will look good. Go to here and make it best fit so that it covers the whole stuff. Here, when you make it best fit, you will see it will be covering the check mark a bit. So for that, you can increase the left from so that you can see here is the ending starting point of the text box. So if you make it so that it's outside of the check mark area, so here maybe 65 actually, it looks good. So yeah, you can see visualization toggle. It might not be properly visible right now, but when you will be playing the game, your background won't be completely black, so it will be better visible. You can change the color to white if you want. It's not a big deal. So the current size that is being used, you can maybe increase this font size to 72 or something if you want. So we'll be using this toggle to control the visualization part for our planes that are being detected. So when we turn this toggle off, the planes won't be visible so that we can play this game better. So for that, we actually will create a script here named, say, toggle AR. And let's drag this script into our, okay, it has opened here. So let's come back here and drag this script into our canvas. And now let's open up the script here. Let's delete this since we won't be needing this. So we'll be actually needing two references here. One is of AR Plane Manager and the other is of AR Point Cloud Manager. So let's write serialize field so that we can feed this references from the inspector panel we have. So AR Plane Manager, Plane Manager. Okay, this wasn't detected. In case this wasn't detected, you can simply write using Unity engine .xr.ar foundation. This should be automatically detected when you're writing, but I don't know why it wasn't detected. So yeah, if it was, you can simply remember this package name when using AR foundation. Next, we'll be needing a AR point cloud manager. So AR point cloud. Here we have our point cloud manager and name it point cloud manager. Okay, we have our two serializable field. Let's create a public method which will actually control the value change from the toggle. So when the toggle is turned off, uh, this method will be actually called and the value of the toggle. So when the toggle is off, false will be passed here. When the toggle is on, true will be passed here. So that, and okay, we need to create another method. This can be a private method. So let's name it visualization status maybe, and we'll be passing it bool status. Okay, done. So here first you have to see that the plane manager, we have plane manager dot enable equals to status. So like if you had turned off your toggle, the plane manager will be disabled. If you had turned on your toggle, the plane manager will be enabled here. So for both, we can handle both the case with a same function. That's what we are trying to achieve here. So now for each, so now basically we are going through all the planes we have already detected and plane manager dot trackable. And what we will do is turn off all the planes that had already been detected. Sorry, STHQS. Yeah. So what we did here is here we stopped the plane manager from detecting any more planes. Here we actually disabled all the planes we had already detected before. So like when you are detecting the planes for placing the game object, or in our case the basketball hoop and the basketball itself, many planes will be detected. And here after detecting those planes, when we turn the toggle off, first the plane manager is disabled, then all the planes that were detected now is also disabled, because if we pass false here, the set active method will be called and it will be turned to false, so the planes won't be visible to us anymore. So we'll do the similar thing with the point cloud manager. So point cloud dot enable equals to false, and similarly we will go through each of the point clouds that had been detected. So ar uh, point cloud maybe name point cloud in point cloud manager dot trackable. So all the point clouds that were detected. Okay, sorry, I don't know what I pressed there. Okay, here. So point cloud. This is basically the variable name we had used. Dot game object dot set active to status. So yeah. So basically we disabled or enabled whatever the toggle status is to whatever to match the toggle status basically. So if you had turned off the toggle, both the planes at the point cloud will be turned off. If you had turned on the toggle, both the planes and the point cloud will be visible again. So now what we need to do is just simply call this function with the parameter we had here. So visualization status. So that's all you need to do for disabling and enabling the visualization part of your planes and point cloud. Okay, so now back to Unity. When we go back over our canvas game object now, we can see that the toggle AR script is actually asking for two references. One is of AR plane manager and the other is of AR point cloud manager. So both those references can be found over here. So in the over the AR session origin, we have AR plane manager and the AR point cloud manager. So let's go back to canvas, scroll down and drag the both those two over here. So both those two have now been linked. Now let's go over our toggle, and if you scroll down, we have a this is basically a listener sort of thing, which on value change is the name, and it has a boolean parameter. So like here, if you see, this is the on state of the toggle. So when this is the state, boolean true is passed, and when true is passed, we set up our toggle AR function to make those planes and point cloud visible. When false is passed here, those will not be visible to us. So let's add to list here and then simply drag our canvas game object here. Okay, we are dragging this canvas game object here because the toggle AR script I had made is over here, so over the canvas game object. In case you had placed this toggle AR script over any other game object, no problem. You can simply drag that game object over here instead of the canvas. So after you have dragged the correct game object here, when you go here, you will see your function here, toggle AR. And since our function there on value change, which we had created, so let me go back to this function here. Okay, so here on value change bool status, since it was asking for a parameter at runtime. So for that reason, this is being listed in the dynamic section of dynamic bool. So we select this function, and now when the toggle is on is passed, true is passed to the function. When the toggle is off, false will be passed to the function. So we have set it up. Let's save us in once. Okay. So this is all done for the toggle and setting up before we actually begin coding the swipe function of the ball. So we are done for now. We'll go into our swipe functionality. So for that, let's create a new script called ball control. Okay. And now let's switch to Visual Studio and start coding for this script. Okay, so now that we are inside our ball control script, let's bring in some variables which we will be using for controlling our balls. So let's bring first of all some serializable field with which we will be controlling how much force we apply to our ball. So let's name the first field throw force and set the default to 100F. And we will also need some damping. Sorry, I had given a damp x equals to maybe 0.1f and damp y equals to 0.65f. So with these two variables, we will be actually controlling how much force we apply to the ball on swipe by the user. Then we need a few more serializable fields. So let's go serializable field. Uh, this serializable field will be a vector3 type, and we'll name this ball offset. And we'll need another serializable field which will actually be the rigid body of the ball. Don't worry if you feel confused right now. I promise you when we finish this script you will be clear as to why we need each of these variables for. I will explain to you the need of each of the variables. Don't worry at all. So we are done with the serializable field here. We actually kept them serializable because we want them to be being modified from the inspector panel itself, and we don't want to come to the script to modify them all the time. So that's why I made this serializable field. Now let's make some private variables of vector2 type. So first is start pulse, then it's end pulse, and the direction. So the start position will have contain the position where your first where you started your touch. The ending position will contain the position where you ended your touch, and the direction will have the direction of your moving. So like if you swipe up, the direction will point up. If you swipe down, the direction will point down. So that's why we needed these three variables, and after that we'll need some float variables. So float touch time start, touch time end, and also time interval. Okay. So this variable name should be pretty obvious. So corresponding to start pose, we have touch time start. So when you begin your touch actually. So this variable is initialized. When you end your touch, this variable is initialized, and the difference of both these two is stored in the time interval itself. So what we will be doing in this game is actually the more time you take to swipe the ball, the more force we will be applying. So you can have other methods also for applying force to the ball. So you could also have done like how much swipe the user had done to apply more force or less force. That was also option, but this is a easier method, I think. So I will be showing this to you. So now we'll need a game object named AR cam. This will have the reference for our AR camera, and bool is active equals to false and check time equals to false. I'll be explaining the needs of all the variables I use here. So don't worry, don't feel overwhelmed or something. I will explain you everything. So now let's come into our start method. First, let us get the reference for our AR cam first. So AR cam can be easily referenced using camera dot main dot game object. So this camera.main actually refers to the camera or the game object you have referenced as main camera in your scene. So if you come to the Unity panel, if you go inside AR Session Origin, you have your AR camera here. You can see it's actually tagged untagged. So we need to change this tag to main camera. And when we have done this, this camera.main will actually reference to the game object that has the tag of main camera. So now let's handle the swipe functionality for our basketball. So let's move inside the update function actually. And first let's check if the ball is active. So whatever swipe functionality check we have, that will be only active if the ball is active. After that, we check if input dot input dot touch count is greater than 0, and the input dot get touch 0. So what we are doing get touch 0 because there can be multiple touch on the screen, but we'll only want the get touch for the first touch we made. And what we will do is check the phase of this touch is equal to touch phase dot began. So here we are checking basically if the touch count is 0. Sorry, I had missed double equals to here. Okay, so here we are basically checking. So if the touch count is 0 and the phase of the touch is began, so the starting point of the touch. So what we will do is touch time start equals to time dot time, and the start pause equals to again input dot get touch 0 dot position. So we have handled the starting of the touch. Now let's handle the ending of the touch. So similar to the start, get touch count greater than 0, and then input get touch again touch 0 because we want the first touch only and the phase of it. So here we have checked if it was touch phase began. Here we will check if it is touch phase dot ended. So if it has ended, we will get the value for the touch time end. Sorry, touch time end equals to time dot time, and the end pause equals to input dot get touch 0 dot position. So now we have the starting time and ending time, and also the starting position and ending position for both the start of the touch and the end of the touch. So when the touch has ended, we can calculate a few variables from here. First is the time interval, which will be touch time end minus the touch time start. Second will be the direction, which will be the end position minus the start position. So basically, how much interval you had touched your screen and at which direction did the swipe happen? We have both the information in these two variables. So now what we will do, we'll keep a small check here, which will be direction dot magnitude greater than 0.2f. This is not necessary for the game. This is just a quality check for ensuring that the swipe we have detected is actually a necessary swipe, because sometimes it happens that we may have made a small swipe unnecessarily. So in that case, the swipe magnitude will be very, very small. So we'll check if it's over a certain threshold, we'll detect the swipe. So this is done. After that, once this is done, we will set the rigid body to is kinematic to true, false. Sorry, false. I will show you the rigid body setup in a few moments from now, so don't worry. And now we will add a force to this rigid body. Add force. So the calculation of the force is a bit tricky, but don't worry, I will try to make you understand how I have done this calculation. So as I have said, we have the AR camera reference already. So we take the AR camera and we take the forward of the AR camera. So if you are facing so the forward is basically the front direction of your camera. So with that, we multiplied the throw force, and as I was telling that we will be calculating how much force we need to apply based on how many intervals you had passed about the touch. So if you had touched your screen for more amount of time, the force will be greater. If you had touched your screen for less amount of time, the force will be less. So for that, we will simply divide it by the time interval. So we have set up our basic force here. Now the problem here is that the force, or we don't want much force on the left and right direction of the camera. We want the force to be applied on the forward. So for that we will dampening up the force here on the both the side. For that we have AR cam dot transform dot up into direction. Direction is basically the direction vector we had calculated here, dot y. So the y component of the direction vector into damp y. And with this, we will be adding another damp force. So transform dot right into direction dot x into damp x. So now let us understand a bit what we actually did here. So first we took the forward. Forward is a Z. So basically we want our maximum force in the Z direction, a little bit damping up in the, so here we have 0.65 damping factor in the Y direction. Y is the upward direction in the Unity scene view, if you remember. And the right is the direction of the X. So a little bit damping up on both the X and Y direction and the full force on the Z direction. So this is what we have done here. After that, we will set the is active here to false. I'll be telling you why we are doing this here, and the check time boolean variable we have taken to true. So we will be using this check time actually to see if a certain amount of time has passed after we had thrown the ball, and then we will reinitialize the ball to the starting position. And for that reinitialization, actually, we will be needing this ball offset. So that ball offset will actually control where we reinitialize the ball into our scene. So for that, we'll pass another check here. So check time. So this check will only happen after you have swiped the ball. So after the ball is out of your screen into the hoop, say you have scored a basket or missed the basket, doesn't matter. After a certain interval of time, we will reinitialize the ball to a position where you can swipe again and play the game again basically. So here we'll check if time minus touch time end is greater than equals to 4f. So here 4f is basically means 4 seconds sort of. So if the time passed since the touch time end, which we have stored here is 4 seconds, we will reinitialize the ball to the its initial position basically. So we will again check time equals to false. So after we have here, since we are reinitializing the ball, we will set the is active to true actually, so that we can again check for the swipe and stuff. And we don't want to keep checking the check time functionality again. So what we have done this, and let's make a function called reset ball, which I will be making in a few moments. So reset ball is done. So now we are outside of the update. Now let's make our reset ball function here first. Okay. So the reset ball will maybe a private or public. It doesn't matter much. I am taking it private public, but you can take it private too. I think it won't matter. Reset ball. So in the reset ball, what we need to do is rb.isKinematic, which we had set up here to false. We'll set it to true. Then the velocity that the ball had, we'll set it to 0. Sorry, not like this. Vector 3.0. And also the angular velocity the ball has, to 0. So so basically the ball is now stationary. After that, we will calculate the ball position based on where our AR camera currently is. So AR camera dot transform dot position plus AR camera dot transform dot position dot forward. Sorry, the AR camera dot transform. Sorry, you don't need the position here. It will be simply AR camera dot transform dot forward into the ball offset variable we had and the z component of the ball offset variable. So as we already know, the forward is actually the z component in Unity. So here we need another offset actually. So AR cam dot transform dot up into ball offset dot y. So let us understand a bit what we did here actually. So we took the position of our AR camera and then in the forward direction we gave the ball a bit offset, and in the upward direction also we gave the ball a bit offset. So I'll be showing you what this offset is in a few moments in the Unity inspector panel itself, so that you can understand this offset thing a bit better. So after we have given the offset, we will simply transform dot position equals to ball pause, and is active as I was telling, we will set it to true again. So we have set up everything. So here this transform will actually refer to the transform component on the game object over which this ball control script is attached. So we will be attaching this ball control script to the basketball game object actually. So this transform will refer to the basketball game object itself. So we don't need a reference to that game object again. So this is simply a shortcut sort of thing. So basically we have made handle the swipe functionality here. We have resetted the position of the ball after some time, and the reset is handled here. Now all we need to do is bring that ball into our scene basically. So as I was telling, that since this ball is also an AR game object, we don't want it to be active from the very start of the game. We want it to be active only when the AR basketball hoop has been placed. So for that we will create a public function actually named sorry, let's keep it cap plus ball. Okay, and what we'll do, once this ball has been placed, we'll parent this ball to the AR camera dot transform, and we will invoke the reset ball function we made after say 0.5 seconds. Okay. So what we did here is basically, once this ball will actually, okay, let me switch back to the Unity view to make you understand better actually. Okay. Okay. So now that we are back into Unity, let me first tell you what that ball offset was for, which we are using actually. So if we go into our basketball game object, we can see that there is a bit of an offset. The basketball is not exactly at 0, 0, 0. It's instead at 0, -1, and 2.5. So this will be actually handled by that ball offset stuff. So let's drag the ball control script over our basketball, and let's set this offset to -1 and 2.5 here. Okay. Now we can see that the is actually asking for a rigid body component here. So let's set up that rigid body. So for detecting collisions in Unity, so since both of this should detect collision, we actually need colliders over both these game objects. So for this, we will be, instead of using box or any simple colliders, we will be using mesh colliders, since these are not simple primitive meshes. So now we have the mesh collider over the basketball hoop, and also for the basketball itself, we'll also use a mesh collider here also. Now the problem of using two mesh colliders is that mesh colliders cannot detect between two mesh colliders, we cannot detect collision until one of them is set to convex. So convex actually means that, let's say I turn this into convex. So if you can see, the whole collider stuff is actually gets messed up here, because we should only set those colliders to convex which have closed and which are actually closed entities. So the basketball hoop is actually a opened entity. So like this doesn't have an end here actually. So we won't be setting this to convex. We instead set this basketball to convex instead. So you can see that setting this basketball to convex instead doesn't matter much. So now both the basketball hoop and the basketball has mesh colliders. You can also use a sphere collider here also in if you don't want to use a mesh collider, it will be fine, no problem. After you have given your colliders, we need a rigid body component here. Okay, so we have a rigid body here. So for the rigid body setup, we will be checking the use gravity. Of course, we want the gravitational stuff to be enforced so that we can get that real feel. But we will be also checking this is kinematics box initially. What this is kinematic box will do is that initially when we start the game, we don't want that ball to be under gravity and fall down simply. We want that ball to be under the influence of gravity only when we have swiped. So that's why if you go back to our script, we had set this rb dot is kinematic to false when we had detected our ending touch. And again, when we had resetted the ball, we had set it to true. So that's what we are doing here. This is done. After that, what we need to do is simply drag this rigid body reference here. Okay, so we are done mostly for the setup. The only thing we need to do now is, if you remember, we actually made a function here called void place ball. So we need to call this place ball after this AR game object is active. Okay, we need to understand one more thing here. So why we are doing this stuff? So transform dot parent AR cam transform. So we are doing this basically. Initially, we are keeping this basketball as a child of AR prefab to be placed game object. But in our game, we want that basketball to be at our center of the screen and move with us. As we move with our phone, the basketball should move with the camera so that it always feels that you are holding the basketball in your hand. So for that, once this AR prefab to be placed is actually active, this basketball actually, the parent of this basketball is shifted from here to the camera itself. So now when you move that camera, say I have that camera itself. So say now I move that camera, see the basketball is moving with me. So that's what the effect we are trying to achieve. So let me switch it back to here. So yeah, that's what we are hoping to achieve. And for that reason, we had written this line transform.parent AR camera transform. Okay, done. Now all we need to do is go back to your tap to place here. And here we basically need a reference to serialized field ball control, CTRL. So why we need this is because initially, as I said, the basketball is a child of prefab to be placed. But when the AR game objects are actually active, we want it to be a child of the AR camera itself. So for that, we will simply get a reference of control here. And when we have placed this object here, we'll simply start CTRL dot place ball. So now once this game object is active in our scene, the ball will pass from the as a child of prefab to be placed to a child of the AR camera itself. So now we can move with the camera and the ball will move with us. So now all we need to do is come back to Unity, go to Manager, and simply drag this ball control reference here. Then save it as always, and we can simply build it. If you had followed our previous video, you should your Unity scene should be configured with all the player settings you need to make for AR Foundation. So after that, you can simply go to Build and Run and simply build this game and play this game. So there you go. You have your very first markerless AR game sitting right on your mobile device. That's pretty cool. So whenever as a beginner we finish a video tutorial on YouTube or say any other platform, we are often left with a question in our mind like what we can do next. Like, as a beginner, we often don't have idea as to what we want to do. So for that, we will be actually doing two things. First, I will be actually giving you a few pointers as to how you can make this game into a good-looking showcase, good-looking first AR project of yours. And second, we will be showing you a few project videos from the XoRphilic community people so that you can have an idea as to what type of applications or games you can make with AR. So for that, for this game itself, my suggestions would be first maybe use different models. So whenever we make an AR game, we don't always need to have very realistic looking models. Like right now, this looks like a sort of a realistic basketball hoop and a basketball itself. So, but you can have a funny looking ball, a cartoony sort of hoop, many things. Whatever you want, you can do with this game. It doesn't matter. It's your game. It's your choice. Do whatever you want with it. Second would be like the scoring system for this game right now is very simple. Like you put this hoop through this, put this basketball through this hoop, so a point is calculated. But that's not always optimal. You should actually, what you should do is calculate the distance between the camera or the player and the basketball hoop. So if the player shoots this ball from a further distance, you should give more score. If it shoots from the less distance, say from, yeah, I'm moving this camera here. So he's shooting from pretty close. So you can give less score or something. So like make this game a bit more dynamic instead of a very static single score 1 point approach. That was basically my suggestion. Third would be a bit of an intermediate level or a sort of hard level suggestion. That would be turning this game into a multiplayer. Now, I wouldn't recommend going into multiplayer as a beginner, of you beginner to Unity on both AR. Right now, you should focus on making this game as a single player version. But if you want as a say far goal of for this project, you can of course make this game into a multiplayer game, and that would be very enjoyable to players because we play basketball with friends, not alone. So that would be pretty cool, I think. As for the videos, project videos I was telling, Apoorv will be showing you those videos in a few moments of time. So have a look at those videos, and I'm sure you will have an idea of what you can make with AR. As for if you have any AR idea but don't know exactly where to start or stuff, you can always join the XoRphilic Discord community, and we would love to help you out there. The link to join the Discord server is there in the description below. So do join and let the community growing.
Thank you, Anirban, for letting me back in. So, if you guys have been following us till here, first of all, congratulations. You have been making a really, really great augmented reality app. And so far, Anirban has been explaining what are the future aspects and what else can you do for making this project much more of what we should say, much more interactive. And I should also say it could be a multiplayer game. Yes, it can be. But I will also be telling you some more future aspects of augmented reality, that is a markerless. Yeah. Okay. So I'm going to just show you some of my projects. Here we go. Projects. So these are the three few major projects which we as a community have been building XoRphilic. First of all, I will be showing you this Snake AR game. This game was built by me itself. I think I made it in after the COVID session started. I don't know, maybe I made it in May or June. So here's the video. So, almost everybody must be familiar with the game which used to come in Nokia phones. The phone which we used in 19. Oh, so I'm so sorry. There was no phone in 1980. We used to use in 2010 back, around 10 years back. You know that small phone with the keypad. There used to be a snake game which eats the food and it just elongates its body whenever it engulfs the food, right? So I just implemented that thing into the augmented reality. So let's see how it looks. So this is just the plane detection, basic plane detection, and there you go. Here's a snake. Okay, whenever the snake eats the food, it grows up. And apart from that, there's also some sort of score. You know, how many food items the snake has consumed, there is a score. So this is a much more interactive way of making augmented reality apps. Yeah, you can interact with the environment because food is being placed again and again, so that you can continue to making you know so that you can continue to eat and eat more and more and increase your score. Apart from that, I would like to show this project. This is one of my favorites because it was built in the COVID session again. But yeah, this project was built by your instructor Anirban. Congrats Anirban for this. So yeah, you can see that once the plane is detected, a map of India is being showcased. And once you see the map, something pops out. What is that? Okay, here's a circular area which shows the name of the state and the people who have been affected by COVID till date, people who have been discharged from that, and the people who suffer death from the COVID-19. That's what is really nice, no? Okay, so far, how I explained that if you will be using Raycast to tap the screen and just place the 3D object. If you have been following my DSC Part 1 Markerless, I have told you that the raycast is being thrown from your camera. Once you place the 3D model, this is actually a 3D model, or I should say a projection of the Indian map. Once you project this map on the ground, okay, whenever the camera sees the place where the location is Madhya Pradesh, or I should say the yellow area, that I should really be preferring to use some of the technical terms. That is the raycast, which I have explained you in the first session only. Okay, so if you face the camera to the yellow region, if the raycast hits this region, the circle pops out and it just tells you the total people affected in that particular area. Okay, let's play this video again. I'll show you how it changes. Okay, so Anirban is not a good recorder, I think. Yeah, he has also used lean touch in this session. Yeah, but I also wanted to show you this something like this. Yeah, as you can see that whenever you change the position of your camera, the raycast is being continuously outthrown from the camera, and if it hits another region, the region where Rajasthan belongs, that is the yellow region which is being popped out. So the region which is being popped out, location is based on that. This is the dynamic data, because whenever you open the app, it fetches the data from the server. We have been using a few features which are not being told in this video, but you can Google it anytime because Google is the best friend of a developer. So yeah, I wanted to tell you this because we have been using Recast and now you are familiar with that. So this was the project where Anirban has created, your instructor for this course. And I would also like to talk about some future aspects as well. So far, Anirban has been giving you some great tips. Apart from these tips, you should be knowing that there are few things which you can work on as well. First thing is instead of using AR foundation, you can also use Vuforia. Yes, I should say come back here. I would just simply search Vuforia. As you have been following this session, we have been using Vuforia for the two sessions. That is the marker based AR1 and marker based AR2. We have been using this Vuforia for these two sessions, but we have been using image target from that. But Vuforia is the developer portal. That means the people who are developing the Vuforia engine for you guys, they have been working hard, and now Vuforia is much more capable of just image target and can also track a model, that is a 3D model, and it can also place a 3D model as we did in the in our video tap to play or tap to place of project, right? Once, if you scan the 3D model, that is the model target generator uploads guidance for model targets. That means there is some kind of guidance interface. That means if you are using a 3D model, or I should say, there is some sort of original model which you are having. Let's see, I'm having a Hot Wheels car at my home. I can just try to just capture that and just create a virtual 3D model instead of that. But now you're getting me, right? So far, Vuforia has also been trying to uh, implement few more things. I'm really liking this Unity AR session, AR Foundation support, because I have been working on Unity AR Foundation, but apart from that, if I also want to work with Vuforia, now there is Unity AR Foundation support for Vuforia. That means at a time I can use AR Foundation as well as Vuforia in my project. This sounds cool, right? Second thing I also wanted to talk about is the SDK download. Okay, I will not start from here. Okay, I just typed the AR Core SDK for Unity. So we have been using AR Foundation package in a project so far. But apart from that, we can also use AR Core package. So here's the link for that. If you search AR Core SDK for Unity, uh, click on this link. This is a Google developers link. So here is the shortcut to download the SDK package for Unity. This is the AR Core SDK package for Unity. I will repeat this. This is just for only Android devices. Yes. The reason I have shifted from AR Core to AR Foundation is that for AR Foundation supports both Android and iOS support. Okay, but if you want to go deep dive into AR Core SDK for Unity, or I should say that you don't want to build iOS device, you are not concerned with iOS devices, or you want to go into a deep dive into the Android devices, I think you should first give it a try for AR Core SDK as well. Okay, so this is much more of a chat. I know you people have been much more bored and really excited to show the basketball application to your friends. So I will not take much of your time. Thank you for watching the video till here. I hope this video is informative, and I was not boring at few points. I know I was a little at few points, but uh, I'm really sorry for that, and thank you for joining the session. And I hope that you can be a great augmented reality developer in future. And apart from that, if you want any help, link is in the description. You can directly give a chat in the Discord server, or you can search for few things. Google is our greatest help, because we are developers, man. Google is our only best friend. So yeah, thank you everyone from me and Anirban. We'll take your leave.